Hello, 6th grade, and welcome to 5.2. Today we'll be discussing ratio tables. For our learning target, it is I can use ratio tables to find equivalent ratios. Okay, starting off with a little bit of vocabulary today. We've got two ratios that describe the same relationship, are equivalent ratios. You can find equivalent ratios by a couple different ways you can do that. You can add or subtract different quantities in equivalent ratios, and this is the method that I would recommend that you do because it's going to be a lot more consistent. Not that the first one doesn't work, but I think you'll start to see that multiplying or dividing each quantity in a ratio by the same number is a lot more helpful. Okay, so again, I would rather see you do that. It's for the majority of problems and even real life situations, multiplying or dividing each quantity in a ratio by the same numbers is a lot better to go with. Usually it's a lot easier as well. And then the last piece, it says you can find and organize equivalent ratios and it's nice to use a ratio table. So ratio table helps organize, helps visualize, all those types of things. I just want to quickly give you an idea of what I'm talking about here. So if you want equivalent ratios, let's just take a pretty basic ratio, say 1 to 2 or a half. If I wanted to make this equivalent, right? So let's say I wanted to make it into 2/4. We know that 2 is half of 4 and 1 is half of 2. These are equal statements. If you look at like a pizza diagram, 1/2 can be represented as 1 half of the pizza is eaten like this, or if you split it into fourths, 1, 2, 3, 4, and you ate 2 of those fourths, you can see that both pizzas have half gone. So they represent the same amount. They're equivalent ratios. Now to go from 1 to 2, if you were to add, on top you'd be adding 1, and on bottom you'd be adding 2. So that's what I mean when I say when you add or subtract, you have to use different quantities to get equivalent ratios. That's kind of tricky, especially when you start getting into different, bigger, more complex numbers. It's easier if you multiply by the same number on top and bottom. So how do we go from 1 to 2? Well, we multiplied by 2, and that stays consistent on the bottom, times 2 to get to 4. So again, I would use multiplication and division if I were you. All right, let's see a few examples. For example 1, it asks us to complete the ratio table, find the missing values, and then write equivalent ratios. Don't forget about this last part. A lot of students forget that in their homework or like on a quiz or something. Okay, so our first ratio is 1 to 3. 1, for every 1 pen I have 3 pencils. Okay, so my question would be, if you were to use multiplication, like I was kind of hinting at doing, how would you go from 1 pen to 2 pen? Well, you'd multiply by 2. So in the bottom one here, to go from 3 to this blank, you'd also multiply by 2. 3 times 2 would give you 6. If you simplified 2 over 6, you would get 1 over 3. So that's like always another good way of checking, okay? And then you might say, well, how do you go from 6 to 9 by multiplying? You can't do that. Well, what you can do is you can ask yourself, how could you go from the original 3 to 9? Well, you'd multiply by 3. So to find our answer up here, we go from our original and multiply by 3. So 1 times 3 would give us 3. Okay, and then write the equivalent ratios. Okay, that would be 1 to 3. Remember, you could also write that as 1 to 3. And we've also got 2 to 6. And lastly, we have 3 to 9. Okay. Now, you also might see the addition pattern. You might say, yeah, Mr. Gillis, we added 1 every time up top, and we added 3 every time on bottom. Yes, that is correct. Okay. But, again, you'll start to see the patterns here. That's a little bit easier just using multiplication. So dogs to cats, for every 4 dogs, there are 6 cats. Okay. How would I go from 6 to 12? Well, if you were using addition, you'd say add 6. But how would you make this blank equivalent? You can't add 6. You have to be adding something different. And it's just a little bit more complicated. So really easy. If you multiply by 2 on bottom, you multiply by 2 on top. And 4 times 2 would give us 8. And then our last blank here, you could ask, how did you go from the original 4 to 24? Well, you multiply by 6. So to find our blank here, we go from our original and do the same, multiply by 6. And that would give us 36. Okay. So this time I'll write them as using colons instead. So 4 to 6 is the same as 8 to 12, which is equivalent to 24 to 36. Okay. Why don't you go ahead and pause the video and see if you can figure out 1 and 2 on your own. All right. For plantains to bananas, 3 to 6 times 2. So I'll do that up top as well. And then to get to 12, well, 4 to 12, you multiply by 3. So do the same on bottom. Would give you 9. So 4 to 3 would be the same as 8 to 6, which would be the same as 12 to 9. Okay. And then for number 2, euros to dollars, times 2 would give us 8. And then from 4 to 32 times by 8, so multiplying by 8 on top, 5 times 8 would give you 40. Okay, so 5 to 4 is the same or equal to 10 to 8, which is equal to 40 to 32. All right. Next one, you have to make your own ratio table. Okay, so it says you're making sugar water for your hummingbird feeder. A website indicates to use 4 parts of water for every 1 part of sugar. You use 20 cups of water. So how much sugar do you need? All right, let's start by making ourselves a ratio table. And we've got a couple things that we're talking about. We've got water, and it's in cups. And we also have sugar, and that's in cups as well. And it tells me that the website says I need 4 parts water, okay, for every 1 part sugar. Okay, and in the end, it says that I use 20 cups of water. Okay, so there's a couple different ways that we can do this. I'll show you both right when we get back, because it looks like I'm running out of time here. Okay, so the first way that I'm going to do this is I'm just going to pretend I have like a 4-cup jar, and I can only fill my hummingbird feeder in 4-cup increments. So I know that I need to get to 20 cups, but I can only go 4 at a time, right? So let's say I upped my recipe to 8, and essentially I'm doubling my amount of water, so I need to double my cups of sugar. So instead of 1, then I'd have 2. Okay, well, let's use another 4 cups. So I'm going to add another 4, it'd be 12. I'm going to add another 4, it'd be 16. And if I add 4 one more time, I'd get to my total number. Okay, well, if I added another 4 cups of water here, I'd have to add another cup of sugar, another 4 cups of water here, another cup of sugar, so on and so forth. So you get to the end, and you can see that you would need 5 cups of sugar if you had 20 cups of water. Now, again, I'm going to reference what I talked about before, but it would have been a little bit easier if you used multiplication right away. And you just said, okay, well, water, I have 4 parts, and sugar, I have 1. In the end, I know I need 20 cups of water. So how do I go from 4 to 20? Well, I multiply by 5, so I need to do that on the bottom. 1 times 5 is 5. It would have been a little bit quicker, but you need 5 cups of sugar. I just want to let you know and remind you that either way will work if you do it the correct way. Go ahead and pause for the on your own 3 and 4. All right, for number 3, you should have come up with 6 cups. And number 4 is 3 quarts. Let me know if you have questions on those. Just for time's sake, I'm going to move on. With example 3, it talks about nutrition facts on a box of crackers. And there are 240 milligrams of sodium for every 36 crackers. Okay, letter A says, well, you only eat 15 crackers. How much sodium do you consume? Well, let's use a ratio table to see if we can't make this problem a little bit easier to solve. Okay, so I have 2 things I'm talking about. Sodium, which is in milligrams, and I've got how many crackers I eat. Okay, and I know off the bat that there are 240 milligrams in 36 crackers. And in the end, it wants to know, or it tells me that I eat 15 crackers. So how much sodium do I consume? All right, so I need to go from 36 in the end to 15. I'm just guessing here that I might need to do a few different conversions or make a few different equivalent ratios to be able to figure that out. So to go from 36 to 15, there's not a nice number I can multiply or divide by. So what I'm going to try to do is I'm going to try to go from 36 to a more compatible number that I know can eventually get me to 15 by multiplying or dividing, right? So what I'm going to try to do is I'm going to try to half my recipe at first. Sometimes that can help. So if I take 36 and I divide it by 2, that would give me 18. Well, if I halved it, I also need to halve my sodium, so that would give me 120 milligrams. Okay. Well, I still need to think about, all right, so I divided this by 2. I still need to think about now, how could I go from 18 to 15? Well, little hint here is think about their common factors that they have. Okay. They are both compatible, or they both have a common factor of 3. So if I could get 18 to 3, then I know I could get 3 to 15. Well, 18 to 3, I could just divide by 6. Let's see, does that work on top? 120 divided by 6? Absolutely. That would give me, 12 divided by 6 would be 2, and then add that 0. So in 3 crackers, there are 20 grams of sodium. And now hopefully you see it, but we can go from 3 to 15 pretty easily by just multiplying by 5. If we were to do that on top, 20 times 5 would give you 100. So in 15 crackers, there are 100 milligrams of sodium. All right. Letter B says that you eat 21 crackers. How much sodium do you consume? Well, without doing the entire problem again, you can use what we've already figured out. We knew that in 3 crackers, that was on bottom, 3 crackers, there was a total of 20 milligrams of sodium. It wants to know how much in 21 crackers. Well, we could go from 3 to 21 by just multiplying by 7. So if I did that to my sodium as well, that would give me an equivalent ratio. 20 times 7 would give me 140. 7 times 2 is 14. Add the 0. Milligrams of sodium for 21 crackers. So making that ratio table can really be helpful come future problems. All right, last one is the real life example. Talks about mixing paint. It says that you mix 3 pints of yellow paint for every 4 pints of blue paint to make green. Okay, mixing blue and yellow to get green, that makes sense. But you use 10 pints of blue paint. So how much green paint do you make? Okay, well, let's set up our ratio. We've got yellow. Actually, I should probably put yellow as yellow. So we've got blue. And we've got yellow. Let me see if I can do this. Perfect. And it tells me I have 3 pints of yellow paint to every 4 pints of blue. Okay. And it says you use 10 pints of blue paint. So again, in the end, I need to get to 10. Okay. Well, can you think of a common factor of 4 and 10 that I could get to here by either dividing or multiplying? Well, they're both even, so they have a common factor of 2. So I could go from 4 to 2 by just dividing by 2. So I'd have to do the same on top, divide by 2. And that would give me, let's see, 3 divided by 2. Well, I could just write that as, oh boy, now I'm going to have a highlighter. Let me just go back to my pen. 3 divided by 2, you could just write as 3 halves, right? And then to go from 2 to 10, well, that's pretty easy. Just multiply by 5. So we have to take 3 halves, multiply it by 5 to figure out how much yellow that I'll use with 10 pints of blue. So 3.5 times 5, so 5 over 1, would give me 15 halves, same as 2 goes into 15 7 times, which is 14. I'd have 1 left over. So that would be the same as 7.5. So if I have 7.5 pints of yellow and I have 10.5 pints of blue, it asks how much green do I make? Well, remember, you combine them to make green. So add your blue and your yellow to get a total of 17.5 pints of green paint. All right, that does it for ratio tables and for today's lesson. Please let me know if you have more questions on ratio tables, and I'll do my best to help. I'll see you next time.